group core project is titled The Sky is Falling, and the members of our group are Renee, Tayler, Danny, and Grace. Our objective is to fill a bucket with water for 2 minutes, and at the 2-minute mark, the bucket that is filling with water will hit the ground after it tips on the seesaw.
First step to create this clock was to create a reservoir to hold the water. We used a 5-gallon bucket to hold the starting water. We also used a 3/8-inch ball valve, a hose fitting, and an adapter so that the water would drain from the reservoir through a clear tube and into an empty bucket on a seesaw. The tube is 10 feet long and clear. It is mounted on a 4x4 plywood board using copper tube holders and screws. The seesaw is a simple machine and was made using PVC pipe and their fitting pieces to create the stand and fulcrum. The seesaw itself is made with wood and planks. Other materials used were an empty bucket to catch the water and another to hold the counterweight. Lastly, a ladder to hold the reservoir.
My name is Renee and I'm going to be talking about the procedure. Once the construction was finished, we had to take certain steps to make sure that the result was the same every time. We needed to have the water at the same level every time the experiment was conducted. We drew a line in the reservoir at roughly 3 gallons and filled the water to that line. When the valve is opened and closed section is created, this keeps water in the tube. We needed to make sure that the same amount remained every time. We drew a line on the tube for where the water ended. We let the water run until it reached 2 minutes, and then we measured that weight. It came to roughly 13 pounds. We experimented with different counterweights and the center of mass on the seesaw in order to find the best counterweight needed to allow the seesaw to tip at the 2-minute mark. We found that 12.5 pounds with a 1 3/8 inch separation from the end of the seesaw, and this was in order to change the center of mass, was the most accurate. Once we found the exact counterweight, we tested the accuracy by draining the tube to the same point, refilling the reservoir to the same mark, and making sure the counterweight was set to the same point each time.
The design principles. The reservoir of water needed to be higher than the empty bucket at the bottom because the pressure of water is directly proportional to the height of the water level as well as gravity. The speed of the water is inversely proportional to the pressure, so the lower the pressure is, the higher the velocity of the water. If the reservoir was higher off the ground, the velocity of the water would decrease. We wanted it to be lower so that the water wouldn't drain too fast and overflow the bucket. As the water level lowered as it drained, the velocity of the water lowered as well. The tube created friction and slowed the water flow. Also, in order for the amount of water at the 2-minute mark to not be too large. The seesaw is a simple machine that needed to be balanced in order to work. The center of the seesaw needed to not shift or slide, so 2 pieces of wood were screwed in on either side around the fulcrum to fix that. In order for the timing to be the same each time, the counterweight needed to not shift. We put all the weight used in a bucket and made sure it wouldn't slide. Friction created by the seesaw rotating needed to be taken into account when testing the counterweights.
For this project to work consistently, we have to look at all of the factors of repeatability and eliminate them. The element of water in this experiment has to be the same every time because the amount affects the pressure and speed. On the seesaw, the counterweight has to be in the same position to stop it from shifting. If it shifts, that could mess up the weight of it, not allowing the seesaw to shift at the exact time of 2 minutes. For the tube that the water travels through, water is contained throughout it. It is kept in there due to the suction from when the valve is turned off. Each time this experiment is ran, the water is held at the same point in the tube, allowing there to be the same amount of water each time. Human error also has to be limited to make sure the time is consistent. The water is measured as 3 gallons and is marked in the reservoir. Human error could be a wrong judgment to if the water hits the exact point on the mark every time. The valve opens immediately as the 2 minutes starts. There may be a slight difference in the reaction time of turning the ball valve 90 degrees, but it is so small that it will not affect the total 2 minutes. This marks the official start time. By limiting all of these factors that may affect the repeatability of this project, we will be able to measure 2 minutes exactly every time we run this experiment.